So in summary, we've talked about entity types and how to model them. And essentially, it's the entity type becomes a table, and all the simple attributes become fields in that table. Now, let's move on to relationships. Here's where we have a little bit of choice. Let's talk about a one-to-one relationship first. So for a one-to-one relationship, we have an example here. S is in a one-to-one relationship with T. And you may recall from the previous example that we said an employee manages one department, and a department is managed by one employee. That's an example of a one-to-one relationship. So how do we model this? We obviously have to connect an employee to a department, and there are three ways for us to do it. Let's talk about the first way, the foreign key approach. The foreign key approach is also known as the two-table approach. And it says you pick one of the entity types and you take its primary key and put it in the other table. This means that we could grab the employee ID from the employee table and we could add it into our department table when we were building it. Or we could grab the department ID from the department table and add it into the employee table when we build it physically. So these are the two choices. These two choices will guarantee that one entity type is linked to the other. So now the only question is, well, which is correct? Technically, both could work. I could put the employee ID in the department table, or I could put the department ID in the employee table. But in this case, remember we want to reduce the number of nulls that we are storing. And we have here, as you can see, total participation between a department and this manages relationship. That means that every single department will have an employee who manages it. So if we were to take the employee ID and put it in the department table, that might be a good idea because every single department would have a value for employee ID. In this way, you minimize the number of nulls. In fact, you would have no nulls since every single department has an employee manager. If we did it the other way, though, if we were to take the department ID that somebody is managing and we were to put that in the employee table, our employee table might have 1,000 employees. Maybe only 100 of them are managing a department. So out of 1,000 records, 100 would have the value of the department ID for the department the employee manages, but the rest, 900 of them, would have null. And so that's why if you're going to do the foreign key two-table approach, you should always do it in a way to minimize nulls. Now, with total participation in the equation, this becomes quite easy to figure out. But what if we did not have total participation? What if we had partial participation on both sides? So this might mean that we have some departments that do not have an employee manager. If that were to be the case, you would still want to take one primary key candidate from one entity type and put it into the other. But do so in a way that reduces the number of nulls. So if 95% of departments had an employee manager, but only 10% of employees did in fact manage a department, then it would still be better for us to take the employee ID and put it into the department table. Yes, there would be some nulls. 5% of our department records would have a null for the employee ID. But 5% of a smaller department table is a whole lot less nulls than 90% of an employee table. And this, in a nutshell, is one of the three ways to map a one-to-one: the foreign key approach, the two-table approach. For our second example of how to model a one-to-one relationship, let's do a different example. Let's talk about students at a university. So students at a university might be patients at the same university through a university health services. So we would say, in essence, that a student is a patient and a patient is a student. And in the student table, I might store things such as your GPA, I might store your major. But in the patient table, I might store other things like your weight, your height, your blood pressure. How should we handle this relationship? Well, one thing we can do is option 2. Option 2 is called the merged relation, or the single table option. So now, instead of having two tables, why don't we just bring them together into one super table? So instead of having a student and a patient, let's forget all that. And let's make a new entity type, a new table called person. And then when we make the person table in our database, we will grab all of the attributes for students. And we will grab all of the attributes for patients, and we will put them together into one new merged table called person. So in this way, this type of approach really truly gets rid of the student table and gets rid of the patient table in favor of a more generic table that can accommodate all the information. And so now we have a very wide person table that will include everything we know about a person. So it will have the student ID number, it will have the GPA, it will have the student's major, but it will also have the patient's blood pressure and the patient's height and weight. Think of person as a combined table that takes all the fields from student and all the fields from patients and puts them into one giant table, one very wide table. There is a third and final way to model a one-to-one relationship, and that is the cross-reference or the relationship option, which is a three-table option. So now we'll keep students in the students table, we'll keep the patient records in the patient table, and then we have to build this bridging table to connect a student to a patient. So, for example, if the student number was 145 and their patient number was patient 2007, then we would build a table that keeps track of that relationship. That would be the third table. And if I had another patient who was patient number 2008, and that corresponded to student ID 150, we would just keep track of that in the bridging table. Then, to look things up, I could start with a student, find out what the student ID was, like 150, and then I could find that number in the bridging table, and then I could see the corresponding patient ID of 2008, and then I could take that and go into the patient table and look up the patient information. So this is a way to kind of keep things separate. All student stuff is in the student table, all patient stuff's in the patient table, and a third table bridges them. In the next slide, we will talk about these three options and why you would choose one versus the other. So in conclusion, there are three ways to model a one-to-one relationship: the foreign key approach, or the two-table approach, the merged relation, or the one-table approach, or the cross-referencing relation, or the three-table approach. Which one should you use? Well, let's talk efficiency. For efficiency's sake, it might be better to have one table. The reason is that the more tables we have, the more places we have to go to look up information, the more expensive the operation is. Queries will depend on things called joins, or I have to join one table to the other. Therefore, the worst in terms of efficiency is the cross-reference option, the three-table option. I would have to use 3 tables, for example, to get a person's GPA and their blood pressure. Whereas if I used the foreign key approach, the 2-table approach, I only have to do 2 joins, because one of those 2 tables will have the foreign key for the other one. But if I did a merged relation, that's the most efficient because I can go one place and grab all the information I need. So then why don't we always use a merged relation in a one-to-one option? Well, the answer is simple. Sometimes we want to keep information separate. Remember, if we had the one table, we could have lots of nulls. If we had patients who were not students, then all the student data would be null. If we had students who weren't patients, then all the patient information would be null. And so we might have one table, but it might be a sparsely populated table. And that might not be good. It's also not as pure. We're not keeping student type of information with a student table and patient type with another patient table. You could consider this for like privacy violations. You want to keep the patient data separate. There's a lot of reasons to keep our data separate. So the foreign key approach is sort of the middle of the road. The foreign key approach will have either some student information in the patient table or some patient information in the student table. But it's only the foreign key. And so that's not a bad idea. But you might not be able to do that. Imagine if you purchased a system to keep track of patients, and you purchased another system to keep track of students in 2 different database systems. It might not be possible to add a foreign key into one of those tables. They might be like 2 separate databases that have to connect. In which case, then, you would probably want to use the cross-reference option because you can't alter the structure of your patient table or you can't alter the structure of your student table. So 2 things are at stake here. The purity of the information. In other words, student table only has student information. Patient table only has patient information. The most pure option would be option number 3, the 3-table option. But it's also the most expensive in terms of joins. The merged option is certainly the most efficient, but it also has all the data mixed together, and you might have a lot of nulls. And the foreign key approach falls somewhere in between the 2. So consider your data needs and consider which of these mapping options works best for the kinds of data that you have. All of them will work. One of them is probably best for you for a particular situation.